We're going to talk today about classifying fingerprints. When we classify things, we put them into groups. Okay, in this case, there's going to be 4 groups: loops, whorls, arches, and then accidentals. The first group that we're going to talk about are arches. Arches are fingerprints that have no deltas or cores. The ridges enter from one side of the print, they rise slightly, and they exit the opposite side of the print. So ridges enter from one side, rise slightly, and exit the opposite side. Here is an example of an arch. Okay, so here's your ridges. They start on this side. Okay, they rise up slightly in the middle, and then they go down, they exit the opposite side of the fingerprint. That would be your definition of a, okay, so they enter one side, they rise up, they exit the opposite side. That's a definition of an arch. A plain arch is the simplest pattern of all. This is what a plain arch looks like. Okay. The other type of arch, so there's 2 kinds of arches: plain arches and tented arches. Both do the same thing. Okay, they both enter one side, rise up, and then exit the opposite side. The difference is how sharply they rise up in the center. A tented arch, okay, you can see the ridges start here, but they go up really sharply. They fall down sharply, and then they exit the opposite side. Okay, so they rise up, and then they exit the opposite side. So the tented arch is just, it rises up sharply in the middle. It looks like a tent, which is why it's called a tented arch. So there's 2 kinds of arches: plain arches and tented arches. And here's the difference between them. Okay, so you've got a plain arch here on the left, and you've got a tented arch on the right. So arches are the first category or classification of fingerprints. Ridges enter one side, rise up, exit the opposite side. The second category or classification of fingerprints are called loops. Loops have 1 delta and 1 core, which we will show you that in just a second. And a loop is where 1 or more ridges enter on one side, and then they recurve and they exit on the same side. So they enter one side, recurve, and exit on the same side. Okay, so you've got, kind of goes up like this, recurves, and exits the same side that it comes in on. Okay, and we'll show you an example of what that looks like. There's 2 kinds of loops: ulnar loops and radial loops. We're going to take a look at ulnar loops first, but first let's look at just in general a loop. Okay, so here's your ridges. Okay, they start on this side, they rise up, okay, they recurve, and they exit the same side that they came in. We said that there was 1 core and 1 delta. The core is the middle of the fingerprint here, and the delta is this triangle right here. Okay, so when we say that loops have 1 core and 1 delta, this is the core and this is the delta. Okay, and then the ridges enter one side, they recurve around, and they exit the same side. Now there's 2 types of loops: ulnar and radial. An ulnar loop opens towards your little finger. So if your hand is palm down, okay, and you were looking at this print from your right hand, say that this was your right index finger, you can see it's entering and exiting right here. It's going towards, this would be where your little finger is. So if this was your hand, here's your thumb, okay, 3, and then here's your pinky, and we were talking about this finger, okay, remember we're palm down. You can see it's entering and exiting towards your little finger. It's an ulnar loop. In order to determine if a loop is an ulnar or radial loop, you have to know what hand the print came from. Here's another example of an ulnar loop. You're recurving, exiting the same side. Radial loops, okay, they look very similar to ulnar loops, except they curve the other direction. So you can see Okay, starts here, recurves, exits the same side. Okay, you've got your core here, you've got your delta here, so one core and one delta. And then if we drew our hand again, okay, if this was from your right hand, okay, so here's your thumb, right, and then here's your fingers. Sorry, not a great drawing of your hand. But you can see that if this was on, say, this finger right here, okay, it's entering and exiting, and it's going towards your thumb. So that's how you know it's a radial loop. So two kinds of loops, ulnar radial. Radial is open towards your thumbs, ulnar is open towards your pinkies. Here's another example of a radial loop. Alright, so we've talked about arches as one classification group. We've talked about loops as a second classification group. The third classification group are whorls. Whorls have one or more cores, which are the centers, and at least two deltas. So they have two of the triangle pieces in them. So one or more cores and two deltas. There are 4 types of whorls. Okay, you have a plane whorl as your first kind. That's where one ridge makes a complete circuit. Makes a complete circuit, spiral, oval. It's like, so if you're looking here, this is a whorl. Okay, so you've got your core right here, you've got one of your deltas right here, and you've got your other delta right here. And if you were to take and do kind of a line right down the middle of your print, it would look very similar on both sides. It displays some degree of symmetry. So plane whorl is where you have at least one complete circuit, and right here is your circuit. Goes all the way around, and then you've got one core and two deltas. So that's what a plane whorl is. Here's another example of a plane whorl, and you can see, okay, there's your circuit, okay, and then here's your deltas and your core, and if you were to draw your line down the middle, it would look symmetrical on both sides. The second type of whorl is a central pocket loop. Do not be fooled by the name. A central pocket loop is still a whorl, so make sure that you highlight that in your notes. A central pocket loop is still a whorl. I don't know why they named it that, but that's what it is. In central pocket loops, they still have a complete circuit. They still have two deltas, but one of the deltas is usually really close to the core, and the other one is further away. So sometimes people accidentally mistake these for loops when they are in fact whorls. So here's your one delta, and then way up here is your other delta, and then here's your core. And notice, if you were to draw a line down the middle of the core, there isn't symmetry in this print. It doesn't look the same on both sides. That's how you know it's a central pocket loop. So it still has two deltas, it still has one core, but it lacks symmetry. Okay, so as far as the whorl category goes, we have plane whorls, we have central pocket loops. Okay, here's another central pocket loop, and you can see you've got your delta here, and then way over here is your other delta, and then here's your core. The third kind of whorl, okay, so we've got plane whorls, we've got central pocket loops. Our third type of whorl is called a double loop. Again, still a whorl, not a loop. Okay, a double loop is kind of two loops combined into one fingerprint. The nice thing about double loops is they're very easy to recognize because they have an S shape. So if you notice right here, the ridges, they kind of form an S within the print. There's two cores, usually, one here and one here, and they usually do have two deltas, but they're oftentimes way out here on the sides and they're hard to see. But the way that you know what a double loop looks like is that it has that S shape. That's a very unique characteristic to double loops. Okay, here's another double loop, and you can see here's your ridge lines making that S in the print. Okay, so for whorls, we have plain whorls, we have central pocket loops, we have double loops. The last kind is an accidental. Accidentals are any other prints that don't fit into one of the three classifications. So there's three classification groups, right? We have arches, we have loops, we have whorls. And within the whorls, we have plain whorls, we have central pocket loops, we have double loops, and then anything that doesn't fit is considered an accidental, and accidentals are classified as whorls. So that's an example of an accidental. That's an example of an accidental. So they're really unique. Like, that would not fit. A loop, a whorl, or an arch wouldn't fit anywhere else, so it's considered an accidental. And accidentals are classified as whorls. That's an example of an accidental. Okay, so why is classifying fingerprints important? Why is that something that we want to be able to do at a crime scene? It allows you to eliminate suspects who are not involved right away. So if I find a plain arch at my crime scene and I pick up a suspect and all they have are loops, I know they're not who I'm looking for. So it allows you to narrow down quickly the type of fingerprint that you're looking for, whether it's a loop, whether it's a whorl, whether it's an arch. Okay, it automatically, even when you're looking at a person's 10 print card, if they only have 2 whorls and the print I found at my crime scene was whorls, I can just look at those 2 whorls and I don't have to look any further. Here's the frequency of fingerprint patterns. You can see that loops are your most common fingerprint out there. Okay, 65% of prints that are found are loops. 60% of those are ulnar and only 5% are radial. Whorls are your next most common type of fingerprint. 30% of fingerprints are whorls. 20% of those are plain. 10% are central pockets, double loops, and accidentals. And then arches are your smallest category. Okay, this one is your littlest one. Only 4% of fingerprints are plain arches, and 1% are tinted arches. So tinted arches are by far the least common fingerprint that are out there. So if you find somebody or you do a 10 print card on somebody and they have all ulnar and radial loops, that's not an uncommon thing. The last thing that we need to talk about is Henry's classification system. The FBI used Henry's classification system to set up APHIS. It basically takes and gives a point value to each finger on each hand. So like your right thumb is 16 points, your right index is 16, your right middle and right index is, right ring is 8, and your little one is 4. And then they gave the same thing. So the left thumb is 4, your left index and middle are 2, and your left ring and left pinky are 1. And the only way for you to get these points is if you have a whorl on those fingers. So if you only had one whorl and it was on your right index finger, you would only get 8 points in the equation. If you had whorls on every one of your fingers, you would get points on all of them. So the only way to get points in the classification system is if you have a whorl. And so here's how it works. They assign a number of points for each finger that has a whorl, and they substitute it into this equation. So here is the classification equation, and it's in your notes. But you only get points if you have a whorl on that particular finger. So here's an example. If a person only had a whorl on their left thumb and their right middle, this is how it would be set up. They would get a 0 for their index, a 0 for their ring. They would get 4 points for their left thumb because that's how much their left thumb is worth. They would get 0 for their middle and little, and then they always put a 1 here so you can't get a 0 as your top or bottom number. And then down here they get zeros for everything except their right middle, which was worth 8 points. So when you add these across, it's 4 plus 1 is 5, and 8 plus 1 is 9. This person's classification number is 5/9, and then they would only have to pull 10 print cards of anybody who had that particular classification number. If somebody had a different classification number, they know they're not looking for that person. So it allowed them, before everything was automated, to pull certain groups of fingerprint cards quickly. Try to find your own classification number in your notes.